In the first video, we covered high-level concepts around React Server components. In this video, we'll be taking a look at an example note-taking application which supports Markdown. This app uses a very simple framework that I have created using the currently experimental RSC APIs. We'll be going through the code of this framework in order to better understand how the RSC paradigm works. So let's get started. Here I have the homepage of the application. On the header, we have two links. Let's go to this My Notes link. On the left hand side, we see list of notes. We see the title of the note and the created date of the note. Both of these are a part of a server component. That is, they are fetched from the database and rendered on the server itself. Whenever we select a particular note, we see the content of that note in the Markdown format. This is also a server component. So we don't even need to fetch the library required for parsing the Markdown on the client because it is rendered on the server. So almost all of the content that we see here is server only. The only client-side bits that we have here is the navigation logic. So whenever we click a note item, we update the URL with the correct ID param, and we have this expansion icon which shows the created date. So one interesting thing to note here is that whenever we go to different notes and bring the content of that node from the server, even then the client-side state doesn't get blown away. So we get a client-only experience, but we are still making use of the server. On the contrary, if we go to the add node page, here almost all of the content is client-only. So if we type in the title and the content of the node, we can see that we are showing a live preview of whatever it is that we are typing. So in this particular case, we do need to fetch the library required for parsing the Markdown as we show the live Markdown preview. So comparing these two pages, the add node page and the my notes page, we can see that this paradigm gives us a powerful choice of rendering our components either on the server or on the client, depending upon what our use case is. We get to have this smooth experience across pages without having to reload even as we are fetching our UI from the server. And the good thing is, we still get to write all of our code as React components. Next, we are going to cover the code base. So let's get started with the folder structure. Here we have the app and the framework directories. The app directory will contain all the code and the files related to the Notes application. In the framework directory, we have the client and the server folders. The client will contain all the files that we are going to bundle up and send as a React client bundle to the browser. This will be the entry point for that bundle, the root.tsx file. The servers will have the RSC and the SSR server. Both of these are Node.express.js servers. If you guys recall, in the first video, we covered on the high level the use cases of these servers. Technically, it could be possible to have them as a single server, but I haven't been able to figure that out myself. The reason for that is if we check the package.json file, in order to run the RSC server, we need to pass this conditions React server. And we require this condition if you want to use any APIs from the React server DOM package. And on the RSC server, we use this package to render our components to the RSC format. But on the SSR server, we use the React DOM server package where we need to render our components to the HTML stream. And if we use this package, we are not allowed to have that condition. So we have a conflict, and that's why we can't use it in a single server. And React probably intends to keep it as separate servers, but I'm not sure what's the reason behind it. So for now, whatever request that we get on the SSR server, we simply forward it to the RSC server. And we do that using the fetch call. So that's probably not the best solution, but we'll keep things simple for our use case. So that was it about the SSR flow. The only difference in the no SSR flow is that we won't be having the SSR server, and in the public directory we would be serving an additional index.html file. In case of SSR, we would directly be rendering the HTML template on server. Next, we are going to cover the no SSR flow, and we'll do that by debugging our application. That way we'll be able to go step by step to understand the flow more clearly. So let's get started. I have already started the application in debug mode, so let's hit reload and we hit our first breakpoint in the root.tsx file. So obviously we are going to load the index.html first, and that contains a reference to the client root file which is our entire bundled up JavaScript. And the entry point for that bundle is this root.tsx file. That's why we hit the breakpoint here. So we call the create root function to create our root. And next we call the render method. And we pass our client root component here. And that eventually renders the root component. But before that, we initialize some global variables. So here we have a call to create component from fetch method, which initializes the data variable. So let's jump to that. And in here, we again call the create from fetch method, which we get from the React Server DOM Webpack package. And it contains a parameter which has a fetch call to our RSC server. So what we are trying to do here is we are going to render the home page on the RSC server, and we'll be passing that rendered response from the fetch API to this create from fetch method. We'll see what this exactly does in a bit, but let's first complete the flow in the RSC server and then come back here. Let's continue and we hit the debug point on the RSC server. Here we have the /RSC route, and if we hit that, we call this get RSC response function. That's why we hit the breakpoint here. We have our path key as /. So the next step is we want to fetch the page corresponding to this path. So for that we need the router. So let's get into this get route function. So I have a very simple router, good old JavaScript object. So given a particular path, we just fetch the corresponding component. In our case, the path is /, so we fetch the home page component. So let's continue. And next we get the client manifest file, but we'll get back to that in a bit. Let's focus on the important bit, that is render to pipeable stream. So in the first video, we discussed the render to readable stream method. This is exactly similar method. The only difference is instead of returning as a web stream, it returns as a node stream. But the functionality still remains the same. That is, given a React component, it is going to render it into the RSC format. It will create a stream and then add chunks of this RSC formatted component. Also, we can see that the page to render component is wrapped inside the server root component. So let's get inside this server root component. And it's rendering a layout component, and we pass our page as a prop to that component. Inside the layout component, we render the header component and finally our page. Header is common across all the components. That's why we have this layout component. And in the header component, we are rendering the links that we have to the different pages. Now up till now, all the components that we saw were server components. The only client component that we have on this page is this link component. So let's jump into that. We can see that we hit some proxy handler function in the React Server DOM package. And this is not how the source looks like for the link component. If we were to check in the code, we can see that it looks something like this. It's a client component indicated by the use client directive, and it's rendering the anchor tags. So we'll get to why it hits the proxy handler function here. But the point here is that render to pipeable stream doesn't care about this link component as it is a client component. Rather, it will be resolved on the browser when we fetch it. So let's continue. Finally, we hit the home page, which is our main component, and we have this message. And once it is resolved, we start piping our response to the client. So let's finish this. So we are back on the client and we were in the create from fetch method. So let's continue and jump into this create from fetch call from the React Server DOM package. We can see that we have the promise from our fetch response, and currently it's pending. But once it's resolved, we call this start reading from stream method. So we'll add a breakpoint here as well. We'll have to wait for the promise to be resolved. Let's get into this get chunk method. And here React modifies the response object, and it will store the chunks into this underscore chunks value. But right now, since we don't have any chunks because we have not parsed our fetch call, we are going to have them as empty. So React will create a pending chunk, which it hopes that it will be resolved in future. So this is how the value looks like for that pending chunk. It is of the type React promise. The status will be pending and the value is null right now. So let's continue. So we have the value of the data variable as a React promise, and the status is pending right now as we are yet to parse the fetch response. And we pass this data variable to a map object where we store the key as different paths. Right now our path is the home page, that's why it is slash. And we store the value as the React promises that we'll get from our create from fetch call. And we are storing it as the initial cache, which we will eventually pass to our use state where we are storing the cache. Again, the logic for cache is very straightforward. It is similar to the router that we had on the server. We are just going to store different paths as keys, and in this case the values would be the responses that we get from the create from fetch call. And the purpose of cache is we shouldn't have to go to the RSC server every time we go to the same page again. Rather, we can just extract the response from the cache. So let's continue. We finally resolve our promise from the fetch call in this create from fetch method. And if you guys recall the streaming video, we know that the response body, the response that we get from the fetch, the body of that response is of the type readable stream, and we pass it to this function. So let's continue in this function. We get the reader from the stream and we call the read method on it. Again, the read method will give us a promise. So we'll pass progress, which is a function which will be fired when we resolve that promise. So yeah, lot of promises. So let's continue and we'll get back here once we resolve the promise. So we get into the root function now, and we hit this breakpoint because we had called the render method earlier and we had passed client root to it, which eventually renders the root component. So we are now into the rendering process. So we initialize the cache and we use the value of the cache down here when we pass it to the use function. I like the verbosity in the API naming here. We'll know exactly when to use it. Anyways, since we are dealing with promises here, we don't have a way of directly extracting the value of a promise on the client. On the server, we could use the async await syntax, but it's not supported on the client. So that's why we have this use method and it can read a value from a promise. Let's add a breakpoint here. We can see that the value of the cache right now is still pending because we haven't finished reading from our stream. So we hope to get into that progress function now. Yeah, we have hit the breakpoint here. So we start reading our chunk from the fetch call now, and right now it's encoded and I have added few lines to decode it. So let's see how the chunk looks like. So this is how the RSC rendered homepage component looks like. We have already discussed this format a little bit in the first video. We don't need to understand everything, but just try to make sense of it. For example, here we can see the message from our homepage. We can see the instruction to load up the client component. That was a link component. We can see this key being referenced here in the header component with the $L5. So the main purpose of this create from fetch function now would be to parse this particular chunk and create a React tree out of it. We already have the server side bits rendered on the RSC server. All it has to do is consume these chunks now and create the tree out of it, which will finally be used to update the real DOM. So we can continue now. Here we receive only single chunk because we don't have any asynchronous logic that will break the stream into multiple chunks. So we get the done as true as we have finished parsing the stream. And finally, if we check the cache value now, down here, we can see that the promise would be fulfilled now. And in the value, we can see the React tree. So if we continue the flow, we should finally be able to see our homepage. Yeah. So this is how the flow for rendering a page looks like. In summary, we make a call from our React client bundle to render a page. We fetch the rendered page from the RSC server and then create a React tree from it back on the client. Next, we are going to discuss the bits that we left out. More specifically, we are going to discuss what all things do we require in our framework to have a working setup of client components. So the first answer is the client manifest file. So if you guys recall, in the RSC server, we had this client manifest file and we passed it to render to pipeable stream method. We get it from the client out directory and it's a JSON file. So this file is generated by this React Server Webpack plugin. So we are using Webpack to create our React client bundle, but along with that we also use this plugin. And the purpose of this plugin is that it's going to generate different client-side bundles or chunks, and the entry point for those chunks will be the files that contain the use client directive. So it's exactly like code splitting, and our code split points will be decided by that use client directive. And I'll show you with an example what I mean by that. So this is the main component for our add node page. This is a server component, but it almost has nothing except for this sections component. So if we go in this component, we can see that it is a client component and it imports our edit node and preview node component. So the moment we declare any component as client component, this becomes an entry point for a chunk that will generate by resolving all these dependencies. And whatever dependencies we import automatically become the client components. And we can even see the chunk emitted by this particular entry point. So this is that chunk, and we can ignore the Webpack specific jargon here, but we can see our edit node component. We can see the sections component and the preview node component. So let's also check the client manifest file. So it will contain all the files that we have marked with the use client directive. It will contain their file URLs as keys, and it will have the value as an object. And this chunks is a important bit. Here it will answer this: what all chunks do I need to fetch in order to resolve the components in this file? So here we see the node module chunk, as we need to fetch the mark library and our original client 0 chunk that we saw. Let's also check that link component which we fetch in the home page. Here we see that we need to load the client file chunk, and indeed in the client file chunk we have that link component. So render to pipable stream will use this information from the object to generate the instruction to fetch this chunk. So we can also check things on browser. Here we had already loaded the home page. So if we check the network tab, here we can see our fetch call to the RSC server, and we can see our chunk here as well. So in the response, we can see that we have the instruction to load our link component, and it will indeed contain that client file chunk that we saw. And in the next call, we do fetch this chunk, and we can see our bundled up link file here. And this is exactly the information from the client manifest file. Here we have the ID, we have the chunk value, and additionally, we have the name of the component as well that we need to fetch. As a file can have multiple exports of the component, right? So we can quickly verify this. If I go to the link component, I have this example component. And if we uncomment this in the header, now I'm also using the example component in the header. So if we reload and if we go to the network tab, we can now see our example component. But the bundle is still the same, that is client file, as it was the part of the link file. So now we get an idea about how closely module resolution is tied around these APIs. If we were to go back to the root.tsx file on our client, where we use the create from fetch method, we can see that we are importing it from the React Server DOM Webpack package. And if we go into this package, we can see that it uses Webpack specific functions to do the module resolution, or for example, fetching our chunks that we saw earlier. And we are using Webpack to generate those chunks. That's why using this Webpack specific binding works for us on the client. On the server, we are not using Webpack to bundle our server side code. I'm not 100% sure, but I think this Webpack is not playing any role here for our use case. It will only come into play when we use server actions, something that we don't have in this framework. And fortunately, that's why our code works, because we don't ever hit the Webpack required statements in this package. React does have other bundler specific bindings such as the turbo pack and maybe the weed binding in future. But for our use case, the Webpack binding suffices. So this was all about the client manifest file. We need to cover one last bit about client components in order to have their working setup, and that is the node register method. So we are going to restart our application in debug mode. So let's go here and let's pass debug. We are going to pass this inspect brk flag. That way we'll hit the first line of our source as a breakpoint. So let's go to the debugger and we hit the first line. This is the file that we run when we call the node process main RSC file, and we can check it in package.json. So when we start our RSC server, we call this main RSC file. That's why we hit the breakpoint here. So this is the node register method that I was talking about. So the purpose of this method is that it's going to modify the module resolution of node in such a way that so whenever it encounters a client file that is containing the use client directive, it's going to replace the exports of that file with a call to create client module proxy function. And this function returns us an object that will contain the information about that module. So we are going to see this in action. And before jumping there, I just want to mention that this file is a common.js file. And the reason for that is the node register only works with common.js files. Rest of all of our code is in ESM modules. That's why we need to transpile those modules to common.js modules. So we use the Babel register method and we use this plugin before importing our RSC server file. So let's continue debugging and we get inside the node register method. So it modifies this underscore compile method of the module object, which is specific to common.js modules. So let's go to the important bit. So whenever it's about to import a client module, we'll hit this breakpoint and we can see this use client as true. And the file that we are importing is luckily our link component. And it just happens to be that because if we check our source and go to the RSC server, we import the server root component at the top, which will eventually import the layout, which will eventually import the link component. That's why we get that link component as the first component when we are about to import it. And it's a client component. So we pass the file URL of the link module to this particular function. And let's see what it returns. So if we check the exports variable, we can see that it returns a proxy object. So a quick brief about proxies. Given an object, proxy object allows us to get access to the getter and setter methods on that object. So the original object is passed as the target, and the function that will be fired when we try to access any variable is this, and it's defined here. So this function will be fired. So let's go back to our original object. So here it is. So this is the information that I was talking about. We have the ID, which will contain the file URL of the module and the type of attribute, which says, hey, I'm a client reference. But how is this information useful? It's useful to the render to pipeable stream method. So as we are in the process of rendering a component, and let's say eventually we encounter our link component. So now render to readable stream will not see the source of the link file, but rather it will see this proxy object. So it's going to use the ID of this client file to resolve the information from the client manifest file. So if you guys recall the client manifest file, it contained the keys as the file URLs of these different client files. And using this ID, now we are able to access this particular object, which will contain the ID and the chunks. So using this object now, we can answer this question, what chunks do I need to fetch in order to resolve the client components in this file? So render to pipeable stream is going to use that object and it's going to create the instruction that we saw to fetch those chunks eventually on the client. So that's the purpose of node register method. So let's quickly go over the rendering flow which we had left off earlier to see what happens when we encounter our link component eventually. Let's get rid of these debug points and hit reload here. So we hit our server breakpoints. So let's continue and eventually get to the link component. So we also had that example component here, which is also exported from the link file. So let's look at this. So we hit our proxy handler function and we can see that we get our target object here and we are trying to access this attribute on that object, which is the name of our component. But right now it doesn't exist in the target object. So this getReference method will attach the information about the client component in the target object. Earlier we just had the information about the file, but now we are going to add the information about the components inside this file. So let's continue, and if we check the return value of that function, we can see that we are attaching this name example component here. It's a proxy object as well. So if we see the target, now it's modified with the example component. And if we continue, eventually we are going to hit our link component as well, which is a client component. And we see here that we are trying to access the link attribute. Right now it doesn't exist. Once we resolve this get reference, we can see our link component appear here as well. And if we check it, we have that name, and along with that we have a slightly different ID. We also append a hash component name to the file URL. Same with the case of example component. And this will be used to finally generate this instruction on the client, which will contain the name of the component. So that's it about the client components. That was a lengthy bit, but I hope now we have a good understanding of how the client components work with this server components. Next, we are going to see how streaming can be useful in case of asynchronous flows on the server. We'll see how suspense can be used to unblock the UI rendering work up until the time we resolve things on the server. So here I have already loaded the home page. We are going to navigate to the My Notes page. I have already added the necessary debug points. So let's navigate. So we hit the first breakpoint and it's in the link component. We call the onClick method, which will ultimately call the navigate function. We have defined the navigate function in the root.tsx file in the root component, and we pass it in the router context. So let's continue, and we hit the navigate method. We have the path as my notes. So right now in the cache, we only have the entry for the home page. So next we'll make an API call to our RSC server. So we hit the breakpoint on the server and the path is my notes, and the page that will render is the notes listing page. So let's go to that component, and the component responsible for rendering the notes is this my notes component. Let's go into that. So here we have the logic of waiting for 45 seconds because I hope that would be just enough for my explanation to complete. So in this component, we fetch the notes from the database. I have a simple SQLite database, and then we use this notecard component to display the note content. So this notecard component is a client component because it will have the logic of navigating to this different notes, which will show the preview. But notice that we are rendering the created date and title as a part of this server component itself, and we are passing them as props to this client component. So that is how we can compose this client and server patterns. So React is not going to block the rendering work just because we have some async logic on this server. Since we have this component wrapped around in suspense in this node listing component, so instead React just shows this fallback component up until the time we are resolving this wait statement. So let's continue and send this data to the client. So as we start piping data, let's go to the client where we left off. So on the client, we'll get our response as a React promise with initial status as pending, and we'll set that to our cache. And once the promise is resolved, we get into our create from fetch method where we start reading from stream. So we are already aware of this flow. So let's continue and we'll get our first chunk. So this is how the decoded chunk looks like. We have the RSC rendered node listing component, which we get as the first chunk. And if we continue our flow, now we should be able to see things on the browser. So yeah, this is the benefit of streaming. Without having to wait for some operation to complete on the server, we can unblock the rendering process using suspense. So now that the 45 seconds have completed, we hit our breakpoint on the server again in our myNotes component, and we can resume our rendering process now. We get our list of nodes as an array. If we continue, now we should hit the breakpoint on the client where we were reading from stream. So we get our next chunk, and this is how the chunk looks like. So we have the instruction to fetch the notecard component, and along with that we have also rendered a list of nodes. So if we continue now and finish this flow, we should now be able to see the complete UI on the browser. So before we move on to SSR flow, I would like to add one thing about caching and routing, and it's about what scope do we have for improving our logic of routing and caching. So for that, let's first select this node and we see the preview of this node. Let's go to network tab. So we can see that we made a call to RSC server and we render our entire node listing page. So let's select a second node and we make an API call with the ID 2, and again we are rendering the entire node listing page. So even if the only part that's changing is the render markdown preview of the node, we are still rendering the entire page, and this is to be expected because that's how our router is configured. Our router and caching logic is very simple. Given a particular route, we check what particular page that is and we render that entire page. So the question is, could we avoid rendering the entire page when only some part of our page is changing? And the answer to that is probably yes. So we could configure our router in such a way that given a particular path, we only render the preview node component, that is the dynamic part on this page. And on the client, if we inspect the RSC response, we can see that we sort of get this key value pairs. And if I understand it correctly, each value is corresponding to a different component. So we could technically parse this individual key value pairs and store them in our cache and only render the dynamic part from the server by updating our caching and routing logic. So could work in theory, and we'll let it just be theory for our use case. So next we are going to discuss the final part, that is how we can have SSR integrated into our workflow. So if you guys recall the first video, we did cover on high level how this could work. So let's quickly recap it. So this is only applicable for the initial load of the page. So from the client, we make a request for a particular route. We receive that request on the SSR server now. Now we simply forward that request to the RSC server for starters. And we have the router configured on the RSC server. So given a particular route, we are going to choose what page to render. And we are going to render that component to this RSC format, or also called as the RSC payload. And once we do that, we now receive this payload on the SSR server. Now we are going to do two things with it on the SSR server. First is we are going to convert it to HTML stream. So it will only contain HTML elements, no JavaScript. And next we are going to attach the same RSC response that we rendered on the RSC server to this HTML stream. And we are going to attach it in window objects. So why do we do that? We do that because we'll use this response to create our initial React tree on the client. So we'll extract this response from the payloads, create a component from it, and then pass it to the hydrate root method. If we compare it to the NoSSR flow, in that we used to directly get this response from the RSC server. In this case, it will be available in the window object as we are loading the HTML. So this is how the entire flow looks like. And for the subsequent request, we are going to fetch the response directly from the RSC server, as this is only applicable for the initial load of the page. So next we are going to debug this flow. That way we can get into the specifics of it. So we are going to debug the mynodes flow. So let's hit reload and we hit the breakpoint in our SSR server. So here, firstly, we are just simply going to forward the request to RSC server. We are already aware of what happens on the RSC server. We are not changing anything there. So we'll get the response. So since it's a fetch call, we know that the response body is of the type readable stream. So next we are going to create copies of the stream by calling the t method. So if you guys recall the streaming video, we create copies of stream whenever we want to use the stream for multiple purposes. So here we are going to use it for two purposes. So the first purpose is we are going to create a React tree out of it, which we'll eventually use to create the HTML stream. And for that, we use the create from node stream method. So this is pretty similar to the create from fetch method that we use on the client in case of NoSSR flow. And we can see that this flow is also pretty similar to what we have in that case. And the reason for that is we can say that SSR server is acting like a client to the RSC server. We are fetching the response from it and creating a React tree from it. So we could have technically used the create from fetch method as well. But if you guys recall, create from fetch method uses webpack to resolve the modules, and we are not using webpack for bundling our server side code. So instead, I use this create from node stream method. It uses node's internal module resolution to resolve modules, so we don't have to worry about webpack. React allows us to use this different APIs based upon what the environment is by this conditional exports. So we can specify what environment we are in and we can use the API specific to that. For example, from the React DOM package, we have mentioned this H. That way, instead of using render to pipeable stream, we can use this render to readable stream, which renders a component to a web stream. So this is how we can use this conditional exports. So coming back to this create from node stream. So the question is, why do we need to worry about modules on SSR server? Weren't the client modules already resolved on the RSC server? We do create the instructions out of them, which we would eventually fetch on the browser. So the answer to that is we need the client components on SSR to create the initial HTML out of them. We are not dealing with any client-side JavaScript. Rather, we are just generating the initial HTML out of these components. So for that, we do need the client components. And the way we resolve them is by using this SSR manifest file. So this is how it looks like. So right now we have the rendered response from the RSC server, which would contain this instruction. And if you recall, they contain the ID and the chunk and the name of the component. So we are going to do the reverse of what we did in the client manifest file. Instead of creating IDs from the file paths, now we are going to resolve the file paths from the IDs, because IDs is what we have from the RSC response. So if we continue the create from node stream method, I have added a breakpoint in the module resolution. So we can see that in the metadata we get the object as we parse the instruction. So here we directly use the import statement to resolve our module, as we are using the node's internal module resolution. So we can continue and we'll hit all the client components. So let's just get rid of the breakpoint. And if we continue, we go to the render to readable stream method. So this is a different method from what we used in the RSC server, because we are importing it from the React DOM package. And the purpose of this method would be to, given a component, it's going to render it to the HTML stream. Pretty similar to render to string method, but now we are dealing with streams instead. So we see our React tree from the create from node stream method. So let's continue. So we declare a reader here from our injection stream. So this is where we had used the injection stream, which was a copy of the original RSC response, and we'll be using that reader in a bit. But before that, we are going to transform our HTML stream and attach our RSC payloads to it. So let's see how it looks like. Here we declare a transform stream, but the transform method will only be called once we start streaming our response to the client. So here we create an injected HTML stream by mapping our HTML stream through this transform stream. And once we start sending the response to the client, we hit the transform method. So we get our initial chunk here, and this is how it looks like. We'll see it more clearly in the browser. So if we continue, next we enqueue the chunk to our internal queue state, and we get to the main part where now we start reading from our injection stream, which will contain the original RSC rendered chunks. So once we resolve the promise, we see this rendered chunk here, and now we are going to attach it to this RSC payload variable, which we declare in the window object. So we declare it as an array, and we'll keep on pushing the chunks that we receive from the RSC server. And we are going to add it in the script tags. So if we continue, Once we complete sending this, we should now actually hit the breakpoint on the client. So we'll get back to this, but if we check the network tab, we can actually see the partially loaded HTML here. We get our RSC payload here, and we can check the browser as well. So we have still not technically loaded our client bundle as we have hit the debug point, and still we can at least start seeing some content on the UI, that is HTML with no interactivity. So this is how SSR streaming provides us a fast initial loading experience. So let's continue debugging our flow on the client. So if we go there, we had hit the debug point in this initial RSC stream file. So how exactly did we get here? So let's first go to the root.tsx file. So in here, we have this call to create from readable stream method, and there we are passing this RSC stream object, which we import from the initial RSC stream. So as we resolve this file, we create this readable stream. So that's why we hit the debug point in this start method. So let's first discuss how this flow is different from what we had in the no SSR case. Rest of all of the things are going to be exactly the same. The only difference is going to be how we get our initial RSC response. So in case of no SSR, we had the create from fetch method, and in there we passed it a parameter which had a fetch call to our RSC server. In this case, we are going to use this create from readable stream method. It's exactly similar to create from fetch. Both are going to create the reactory after receiving the RSC payload. The only difference is we are going to pass a readable stream to this method, which we are going to create ourselves by extracting the RSC payloads from the HTML stream. So if we go back to this file, so here we have the logic for extracting the RSC payloads. So whatever RSC payloads we have till now, we are simply going to call this handle chunk method on them, and it is going to encode that chunk into our readable stream. And whatever chunks that we'll receive in future, we are going to monkey patch the push method that will do the same job of encoding the chunk. And we monkey patch this method because if you guys see the HTML stream, so we are directly calling the push methods on whatever payloads we receive. So as we call this method, this push here will automatically be fired, and instead of pushing it to an array, it is going to encode it into a readable stream instead. So this is how we'll add chunks to our stream, and it will be consumed by the create from readable stream method to create the reactory. So let's add some debug points here, and if we continue our flow, so we have already received our first RSC payload in our HTML stream. So we are simply going to encode it to our internal queue state of the readable stream, and we can continue, and we can start creating our reactory. So if we continue, now we hit the breakpoint in our SSR server. So if we go there, here we receive the next chunk from our RSC server. We have finished resolving the wait statement in our mynodes component. So if we continue, we should be able to see the response. So this is the second chunk with the instruction to fetch the node card component and our rendered nodes list. So let's encode this chunk, add it to our RSC payload in the script tags. So let's continue. Finally, we are finished parsing both the chunks from the RSC server, and along with that, we'll also get the equivalent HTML chunk from our render to readable stream. So let's continue, send that as well. And we have already done this. So before closing our HTML stream, let's go back to our client and collect these chunks. So we get our second chunk in the push method. So let's encode that in our readable stream. So finally now we should have received our second payload, and along with that the HTML for it. We can see our nodes listing here. So all that's left now is to close this HTML stream. So if we go to the SSR server, so this is the final chunk that we get from our HTML stream, indicating that we have finished creating the HTML from our RSC chunk and we are ready to terminate the stream now. So if we continue, Now we should be able to see the notes listing page loaded completely on the browser. Also, if we check the network tab, we see this small JavaScript emitted. It's emitted as a part of HTML stream, and it relates to how suspense HTML elements are resolved. So if you see here, we have this fallback text from our suspense component, and the actual suspense component appears as a template component with an ID. So as our HTML will eventually be resolved for the suspense component, React will use this logic to place the new HTML into correct suspense slots. So we can see here that the new HTML that we get has this ID as 0, and we are calling this $RC function, which will replace this HTML into this suspense slot. So with that, we complete our entire flow for SSR. Thank you.